Hi viewers, this is Sri Ramulu. Today's topic is growth of charge in LCR circuit. Consider a circuit having a capacitor of capacitance C and inductance L and a resistance are connected in series as shown in figure. So here in the below figure, these are the shown. Once again see. Here L, R and CI, these three are connected in series, and here there is a key. S is a key or a switch you can connect through towards B or towards A also. This combination is connected to a battery of EMF E by throwing a switch S to a point E. So if you connect it like this directly to the A, then what happens? It forms a circuit, closed circuit like this. See here, it forms a closed circuit. In this manner, it forms a closed circuit. Okay. So when S is connected to A, next, let Q be the charge on the capacitor and I be the current in the circuit at any instant t, means at any time, that is the meaning. At any instant means at any time. The potential difference across the capacitor will be Q by C, while the self-induced EMF in the inductance will be L di by dt. These are opposite to the EMF or E of battery. Here Q by C is what? It is a potential difference across capacitor. This also potential difference across inductor. Okay, and these two are opposite to what? Battery. So the effective EMF in the circuit will be, so it is effective. Just now I said you here Q by C and this L into di by dt works opposite to it, means they are opposite, means minus. So next, according to Ohm's law, this must be equal to Ri. So what is the Ohm's law? Ohm's law is the potential difference is equals to product of resistance into current. So this is a effective is what? It is equal to R. But what we have to do here? We have to change the above equation, this equation completely in terms of Q only. So here you have the I and I, so replace replace them by dq by dt. Why? Current is equals to charge by time. Okay, so to this if you differentiate one time with the time, then you can get this one. Okay, so when you differentiate to it, then you get this one. Okay, I is equals to dq by dt, charge by current, charge by time is current, and substitute in the place of I this one, and in the place of di by dt this one. Now, so here in the place of di by dt this term, so substituted. In the place of I, dq by dt substituted. Okay, now what we have to do? So how many terms in minus are there? Simply bring them other side. So bring this side, and it is also this side. Why? These two terms are minus, and already there is a one term plus, so don't change it. So first to write them from square order. So write square term first and next without square. So see here, so it is brought this side, so in this term you have to write first. Okay, and next this time, and next if you bring this minus Q by C this side, write them, and keep it E that side only. So key E is kept that side without changing. Why? That side it is a positive. Now divide the above equation with L on both sides. When you divide, here L gets cancelled, here R by L, here Q by LC. Is it this one? Now substitute. So here certain substitution we have to take place, and R by L substitute simply 2k 1 by LC, right, omega square. So above equation it changes as, see above equation how does it changes? So here in the place of this 2k, in the place of 1 by LC is omega square. Now bring E by L this side, E by L this side. So when you bring this side it is a plus, if you bring this side it minus, and this side is 0. And from this factor only, from these two factors only, take common omega square. From this and this take common omega square, then you get this one. If you multiply again this inside it, then you can get again this one only. So check it whether it is correct or not. Now let it is a equation number 1. Now let x is equals to q minus E by omega square into L. Okay, so let this box as x only simply, and differentiate this equation. Okay, one time, differentiate one time, you can get like this. So differentiate twice. Why it is dq by t, why it is not coming, means it is a constant term. If you differentiate with time, that becomes 0. So only q will differentiate. So dx by dt, it a dq by dt, this term is 0. So dx by dt, dq by dt. Again if you square it, d square, again you differentiate it, d square x by dt square, d square q by dt square. Now replace, so substitute them in equation 1. So in the place of d square q by dt square, d square q by dt square, substitute this one, and in this place substitute this one, and at the bracket substitute only x. So the equation becomes like this. Let this is the equation number 3. Okay, so if you observe the carefully third equation, so third equation is a second order differential equation, isn't it? Second order, here square is there, so that is where it's second order differential equation. So such questions, such differential equations we have observed in the first year, first sem. So there you know how to calculate its solution. So its solution we have to assume as x is equals to either exponential or in terms of sine or cos. So here exponential terms are taken. X is equals to a e power of alpha t. Differentiate one time. Okay, you get this one. Differentiate twice. Again you can get alpha downside, and already one alpha is become alpha square. So y, its formula is e power of x, e power of alpha t formula is what? Generally it is in the form of ax. When you differentiate like this one, so you have to write a into e power of x. So whatever factor you have, coefficient you have to the x, that comes downside. So here a you have, so it comes downside. Here also same thing, here also same thing. Now substitute above values x, dx by dt, d square by dx square, substitute them in the equation 3. Okay, so equation 3 is this one, and in the place of this, so it is, and in the place of this, this is, at the place of x, at the place of x, write this one, so written. And common factors are there. A into e power of alpha t is common, so take it and make it to 0. Okay, so after taking common, so you can get this one. So it is a quadratic equation. So its solution, we know when suppose ax square plus bx plus c is equals to 0 is there. Okay, then its general solution can be written as, so x is equals to minus b plus r minus under root b square minus 4ac by 2a we have to write. But so for square coefficient is a. Here square coefficient is nothing, means so you have to understand it as 1. Next, x coefficient means here alpha coefficient 2k is there. So that means here alpha x coefficient b. So b is equals to 2k here. And here omega square is there. So that is simply c. So in the place of c is equals to what? That is omega square. So substitute a is equals to 1, b is equals to 2k, c is equals to omega square in this equation. Then what you get, you know, so you get this equation. Okay, and take upside 4. If you take 4 outside, so from it square under root, so you can get 2 gets cancelled. So finally you can get this one after simplification of this. Next, here two solutions has come. One is C with a plus and with a minus. Two solutions has come. So for this the general solution equation is, see here, x is equals to, so above what is given, x is equals to a into e power of alpha t is given just, isn't it? But in the place of alpha, what you have the two values. One is a plus value, other one is a minus value. Okay, so then when you substitute here the plus term, make it as 1, and after placing substitute minus term and make it as constant as 2. So same thing is written, a1 a2. So here plus term is taken, here minus is taken. Okay friends, why these two has come? So like this only. Here where a1 and a2 are the constants, the values, constant values, not the values, constant values, and these constants can be obtained by applying boundary conditions or beginning conditions. So boundary conditions are beginning conditions. So equation 2, what is equation 2? This is the equation 2, you know, it is equation 2 already we have done. From this, right, x is, q is equals to, okay, bring this side, it become plus, so we can get this one only, and substitute x value just now above what we got, above see x value, x is equals to this one we got, and substitute that x value here, then you can get this one. Okay, now x is substituted, right, and take it outside and simplify it. E by omega square L, omega square term we know omega square is equals to 1 by LC, substitute L cancel and C goes upside. So here voltage into capacitor gives simply charge, but it is a battery voltage, then battery contains a charge, that is maximum charge Q naught, so that is why we have written Q naught. Next, where Q naught is final steady charge on the capacitor. Next, during the growth of charge, so during the growth means at the beginning it is a boundary conditions, at the beginning time is equal to 0, so charge you cannot get any charge at the beginning, growing time, but decaying time is different. At decaying time means time not started, but in decaying maximum charge will present. Why? Already previously it is charged, when it is fully charged then only we discharge, but it is second condition, it is not here, it is in decay only. So in growing we take this one, growing means not growing started, not started means time is 0, then charge also cannot be starts. Okay, so here this is equation 4 over. Next to substitute the boundary condition in the equation 4, q is equals 0, t is equals 0. So q 0, t 0, it is 0, and here 0 and here 0, so then exponential terms is 0, e power of 0 is 1, e power of 0 is 1, so here 1 into a2 only, 1 into a1 only, and q naught as it is. So we got this, from this we can get this one, let it is equation number 5. Now what you have to do, differentiate equation 4 with respect to time. When you differentiate it, so dq by dt is what? Current, it is written as I, and here see exponent t coefficient, it comes down, so t coefficient is this one, came down, here also t coefficient is this one, it came down into constants, right? Now conditions, at the time t is equals 0, charge is not started means current also cannot start. Okay, so current 0, substitute current 0, and time 0, here also time 0, so this time is 1, right, this time is also 1, why? E power of 0 is 1, right, e power of 0 is 1, so this and this remains constant with constants. Okay, so then we can get this one and multiply a1 and a2 inside, so this is, and take out the common, here take out common k, then you can get this one, here this root take out, so you can get like this. Okay, and here a1 plus a2, just now we have got above a1 plus a2 is equals to q naught, see here where it is, so equation 5 is what? See, all right. Now so a1 minus a2 is this one, while after bringing this is this side, it becomes minus, and bring this under root terms and it goes downside, so it is a2, let it is equation number 6. Now solve the equation 5 and 6. How we solve? We know how to solve, so that is written here, and just add them plus. So after adding, these two gets cancelled, a1 plus a2 becomes 2a1, and these two added, so like this we got, and from this take outside common q, take out the common q naught outside, and to bring this side it becomes like this, minus q naught is taken. Okay, so minus q naught, and to bring this side, so we get this one, substitute a1 in the above equation. Okay, so above equation is what? In which equation? In this equation. First bring this a1 this side, a1 is plus, first bring a1 this side. Okay, so then we can get write like this, and substitute a1 value. a1 value already we got here, substitute here a1 value. So a1 is minus, with minus started, already here a1 is minus, minus minus become plus. Okay, now multiply the q naught by 2 inside, so it is we get, and here minus q naught and plus q naught by 2 becomes minus q naught by 2. So here minus q naught by 2, and take out the common, so you can get this one. Okay, so after taking common, so you can get this one. Okay, one step is decreased. Now here a2 we like this, a2 we get, so a1 a2 we got, and substitute them in the equation 4. So what is the equation 4? This is the equation 4. So here a1 substitute and a2 value here substitute. Okay, so after substitution, it is equation number 4. So here in the place of a it is substituted, in the place of a2 it is substituted. Let it be equation number 7. Now consider the following cases. 3 cases will arise. What are those 3 cases? First, you must keep in mind the equation, 7th equation, very very important. 7th equation is important one to us. When k square is greater than omega square, k already we have taken as 2k is equals to L by R we taken, but from this k we can write L by 2R, and square it L square by 4R square, R square by 4L square. K value we have take 2k as we have what we have taken, R by L we taken, brings to this side, it becomes like this, square it, R square, L square, it become 4. So like this, omega square we know 1 by LC. Okay, so this case is called over damping. Okay friends, it is called over damping. So in this case, when k square is greater, now see, it is take outside root, what, under root of k square minus omega square. When k value is very much high, high means this is a positive term, so it is lower means negative term. So when it is high value is positive, then its result is also positive, then from the root also positive value we get. So it is positive, this is also positive. Okay, it is negative, it positive, it negative. Then what happens, you know, current charges increases slowly like this. Okay, so it is it is a over damping. First line indicates over damping, slowly increases like this charges. But when k square is equals to omega square, so substitute k square is equals to omega square, this term 0 and this term is also 0. Okay, so you can get e power of minus kt, e power of minus kt you can get, isn't it? Then what happens, value increases very fast, rapidly. So it is a second diagram. Okay, so in the second diagram gives rapidly increases. Next, when k square less than omega square, it is called under damping, it is critical damping. In under damping, what happens here, what happens, see the diagram, see it, so take it outside, what, k square minus omega square. When omega square is greater, already is minus, so from root negative term we will get. Okay, imaginary term we get. So then solve it. We have the solution for under damping only. See here. In this case, k square minus omega square is imaginary. Okay, let take outside minus from this. So from this, so we can get like this, and separate them, separated here and here. So I square is equals to generally minus 1, but from this I is equals to we can write root minus 1. So it is a I value, and let it is as a beta. Okay, beta is what, under root omega square minus k square, omega square minus k square. From equation 4, it is equation 4. Now substitute in the place of this, what, under root of k square minus omega square is simply I beta. Just now above we have taken, see here. So this is written as I beta. Now substitute I beta in the equation. Here I beta and here also I beta. Now multiply t value inside and separate it. E power of minus k plus I beta can be written as into t. can be separated as minus kt e power of I beta t. So like this it is separated here and is also separated. Now take outside common factors. So this one and this one common factor, so taken outside, inside it is. But we know the formula, exponential formula. E power of plus or minus I beta can be written as cos beta t plus or minus I sin beta t. If it is plus, take plus term. If it is minus, here take minus term. So here plus term we have and minus term we have. So first write with a plus and next here with minus. Okay, now take cos beta t common. So here a1 and here a2. So a1 plus a2. Now take I sin beta t outside. I sin beta t here a1 and I sin beta t here minus a2. So then what do you get? You get like this equation. Now already we know this term. Just now above we calculated like this, and it is also we calculated. Okay. So in the place of this, simply I beta is substituted. Okay, substitute this above equation here, then here you can get like this. Take outside. Now what you have to do now? Here I and here I cancelled. Okay, then this one. Now take common factor. Common factors are minus q naught and minus q naught. Yes, minus q naught is taken outside. Now take LCM beta. So beta here it is multiplied by written is by beta is written. Take outside beta common. So beta is written outside. Then this equation. Okay. So here what we have to do, substitution method we have to take place. We have to write and let beta as beta is equals to k sin alpha and a small k is equals to k cos alpha. Here capital letter is taken here. Okay. Substitute these values here. Then what you get? You get like this. Like this you can get. Okay. In the place of beta, in the place of k substituted. Now common factor is k. Outside is k is taken. Okay. Here k is there. Here k is k outside. Now let it is sin a cos b plus cos a sin b form is there. So then what we can write? Sin of a plus b we can write. So that formula is applied here, and finally it is written like this. So this is the final formula and a beta value. So beta value substitute here. Here wherever you have the beta formula, so replace that with under root. So it is here and here replaced. This is the final formula. So thus the charge is oscillatory and time period is given by. So sign indicates what you know, charges it changes like this. Okay, so same diagram is shown here. See here, this is the for third only, this diagram. It is the first case, second case and third case. Third case is bigger one. So finally we got a sine. So sine wave is come. So that means it sharply increases first and later increases and decreases, increases and decreases. So it fluctuates at the end. Now the time period. So it fluctuating means time period. Time period, time is equals to 2 pi by beta. So beta term we know, in the place of beta it is substituted. And frequency, for this frequency also we have to calculate. Frequency is what? 1 by time period. So f is equals to 1 by time period, and this t value is substituted. So finally, and omega term and k square term is substituted. So this is the frequency of LCR circuit when the charge is growing. Okay friends, so don't forget this video watching till the end. Thank you.